In this series of lessons, we will study the p-test for series. The p-test tells us that the sum from n equals 1 to infinity of 1 over n to the p, so this series converges if p is greater than 1 and diverges if p is less than or equal to 1. Let's start with the case p is greater than 1, and then we'll look at the other cases separately. So if p is greater than 1, notice that the function f of x equals 1 over x to the p, so if p is greater than 1, this is a continuous, positive, and decreasing function. So f of x equals 1 over x to the p is continuous, positive, and decreasing. So that all tells us that we can use the integral test. So the integral test tells us that we need to compute the integral from 1 to infinity of 1 over x to the p dx. So this is an improper integral, so the first thing we do is rewrite it as a limit t goes to infinity, integral 1 to t. I know I'm going to integrate, so I'll write this as x to the minus p dx. So we get limit t goes to infinity. So to integrate, we add 1 to the exponent, so we're going to get x to the minus p plus 1, and then our coefficient out front becomes 1 over minus p plus 1. And we're integrating from 1 to t. So we get limit t goes to infinity. So the 1 over minus p plus 1, I'm just going to write that as 1 over 1 minus p, and I'll leave that out front. So then we get t to the minus p plus 1 minus 1 to the minus p plus 1 when we plug in our bounds. So now we get limit t goes to infinity, so we have that 1 over 1 minus p out front. So the t to the minus p plus 1, we need to take the limit as t goes to infinity, so I want to think about what that expression is equal to. So t to the minus p plus 1, notice I can write this as t to the minus p minus 1, so when the minus goes through we get minus p plus 1, which is the same thing as 1 over t to the p minus 1. So for example, t to the minus 7 is just 1 over t to the 7. So this is going to help us take the limit, so we get 1 over 1 minus p, we'll write this as 1 over t to the p minus 1, and then 1 to anything is just 1, so we have that minus 1 there out on the end. So now let's think about what happens as t goes to infinity. So the 1 over t to the p minus 1 term, so again, p was greater than 1, so that means this is 1 over t to some positive number, which means as t goes to infinity, 1 over t to the something is just going to 0. So as t goes to infinity then, the limit that we get for our improper integral, we just get 1 over 1 minus p times 0 minus 1, or negative 1 over 1 minus p, and a slightly nicer form, this is how your book writes it, if I multiply top and bottom by minus 1, we just get 1 over p minus 1. So what we've seen here is that the integral 1 to infinity, 1 over x to the p dx, this integral converges if p is greater than 1, and in particular the integral converges to 1 over p minus 1. So thus, by the integral test, we get that the series sum n equals 1 to infinity, 1 over n to the p, this series converges if p is greater than 1. Again, note that the series doesn't converge to 1 over p minus 1. All we know is that the series converges. We don't know what the series converges to. So this is the first part of our p-test. The series sum n equals 1 to infinity, 1 over n to the p. This series converges if p is greater than 1.